All right, so good morning. This is January 30th, Math 0310. A couple of announcements here to get started. For all of you that are with me live and all of you who are watching the recorded version, WebAssign homework, your first WebAssign homework was due January 28th, and so that date has now passed. The next date is February the 4th for the next couple of sections. Pretty much WebAssign will be due, WebAssign homework of some type will be due most every week the rest of the semester. So be looking for those due dates and pay attention to those. And generally speaking, unless there's some really extenuating circumstance, I am not going to be adjusting those due dates at all. So generally speaking, unless something really weird happens, or if we get behind in the material for some reason, I am not going to be granting extensions generally on homework. I do drop the 4 lowest grades, and so because I drop the 4 lowest grades, you do have some leeway there. So if you went through the first couple of assignments and for some reason you missed some due dates and you didn't get those first couple of assignments done, I drop a couple, and so that's not going to show up on your final average at the end of the semester. Also remember that the grace period is just about over. It expires tomorrow, January the 31st, and so after tomorrow, if you have not paid for an access code, you will no longer have access to WebAssign until you pay for an access code. And so please, if you have any question about that, or if there's some financial issue that you need to make me aware of, then talk to me about it, and we'll see what we can work out. I'm kind of limited in what kind of power I have there, but we'll at least give it a shot. So most of you, I think, now have purchased the access code, and you're good to go. But if you still are in a position where you haven't done that, try to get that taken care of so that you can keep up with your WebAssign homework. It is very easy to get behind on WebAssign stuff, so keep up with it. Exam 1, okay, the review is posted, so I want to make sure that you know that. And it is at the bottom of, the link is at the bottom of the Google site, and so go to my Google site where it says exam reviews, and you'll find that review posted. It is a very long review, so that's good news for you, because what that means is that I'm just giving you lots and lots of practice problems. All of the worked out problems are on there also. Not only have I given you problems on there, I've also got the solutions on there as well. I think the review is like 20 pages long altogether. And so it's, like I said, there's lots and lots of practice problems and the worked out solutions in there. So take advantage of that review. If you can work that review, then you're going to be in good shape on exam 1. Try to do as many problems as you can on that review without any help, any notes, any person, Google. Try not to do any help at all, and see how much of that you can do without that. So I would work 4 or 5 problems, then check your solutions, see how you're doing. Work 4 or 5 more problems, check your solutions, see how you're doing. And then the places where you're struggling, then that tells you, okay, I need to go back to the textbook and to the notes and work some more problems there, and I need more practice, right? That'll give you a good idea where you've got, where some more practice is required. The exam 1 window is from February the 8th through the 13th. So, and somebody asked about this at the beginning of class today before I started the recording. You take that test at a testing center in the Lone Star College system. I'll send the test out to all of the testing centers in the Lone Star College system. And so you do not need to make an appointment. You just go to the testing center on that campus and make sure that you have a student ID or some kind of a photo ID with you, and then you can take the exam. I would allow I will put probably a 2.5 hour time limit on it. That should be easily enough time to finish the test. Most of you will finish it in 1 hour and 15 minutes to 1 hour and 30 minutes probably, but you'll have lots of time to take it. I would allow myself at least 2 hours, at the very least 2 hours to take the test. So if the testing center that you're going to use closes at 8 p.m., make sure you get there by 6 p.m. to take the test, to allow yourself at least enough time to take it. And then what happens is that testing center will scan the exam, and then they'll send it back to me electronically, and then I'll grade it electronically on my iPad, just like a sheet of paper. And then I'll have a copy of the graded exam. And if you want a copy of your graded exam, oh, and by the way, the grades on the exams will then get posted in your WebAssign gradebook. And I'll give you some instructions on how to look it up on your WebAssign gradebook at the beginning. So you can go and look at what your test grade is. And if you want a graded copy of that test sent back to you, then just email me and I'll just send you an email back with an attachment that's your graded exam. So that's not a problem at all. On campus hours, before each exam, I will be on campus for face-to-face office hours for 2 days before each exam. So February 7th and 8th next week, I will be on I'll be on campus on the North Harris campus in Winship 115K, available for help. So if you have any questions, you can actually stop by and say hi and go over some problems with me, or if you have some material questions of some type, I'll be happy to help you out. Online office hours as always, Sunday and Tuesday 8:30 to 9:30, and then Tuesday, Wednesday, Thursday 11 a.m. to 12. And then, so any questions on any of that before we continue on? Any of you who are with me live today, do you have any questions that you want to ask me about any of that kind of stuff?
You said we're able to go to any campus to take the exam, right? As long as we're in the testing center?
Correct. So, some of you will be taking it.
Go to the Kingwood.
So I'm sorry, say that again?
I was asking, so I can go to the Kingwood location and take my exam.
Yep. Now, Kingwood in particular, make sure that the testing center, I guess the testing center at Kingwood is open. I know some parts of the campus still aren't open after the hurricane.
Yeah, that's right.
But just make sure that the testing center is open. I believe it is, but that is one thing that you need to check on, obviously. And for all of you, wherever you're going to take it, if it's going to be Cy-Fair or Cypress Creek Center or Montgomery or wherever, just check and make sure that you know what the hours are for the center that you're going to use, and make sure you know where the center that you're going to use is actually located also, so that there's no issues there as well. Any other questions about any of that?
I'm sorry.
No, go ahead, Taylor. What's up?
You're going to be at the North Harris location, right, for the in-person?
Yep, that's where my office is. Winship 115K, February 7th and 8th, and love to have all of you come by for help. Absolutely. So, last semester, by the way, had very few people come by for help during my on-campus hours. I had one or two usually every time I was on campus. Occasionally a few more, but mostly just one or two. And every one of those people that came by passed my class, by the way, just so you know. If they were conscientious enough to come by for help, that meant that they were organized enough to be working on the class pretty hard. And so all of those people ended up doing fairly well during the semester. So, all right, today then we are leaving. Last time we finished up our discussion of polynomials, so we had been talking about factoring polynomials, and so now we're done with that. Doesn't mean we're done with it. It doesn't mean that you no longer have to worry about factoring polynomials. In fact, that's going to come up relatively often for the rest of the semester and into college algebra. In any math class you take beyond college algebra, there's going to be some factoring of polynomials occasionally that's going to come up. So don't think we're going to be leaving that. But what we're going to do is move into chapter 8 today, and we're going to start talking about rational expressions. And in particular, we're going to be looking at what it means to simplify a rational expression, and then looking at multiplication and division of rational expressions. We're actually going to go through operations on rational expressions there. So the first thing to talk about, at the beginning of talking about polynomials, we talked about what a polynomial was. So certainly you need to know the terminology that we use in algebra, and so you need to know what a rational expression is also. A rational expression is simply a fraction, but it's a fraction that's in a very special form. It's a fraction that is a polynomial divided by a polynomial. Right? That is what we mean when we're talking about a rational expression. So anytime you hear your algebra instructor for any class after this referring to a rational expression, always remember that that's what they're talking about. They're talking about fractions When they're talking about fractions that have polynomials in the numerator and polynomials in the denominator. So these are all examples of rational expressions, what I'm writing down right here. So 2x squared y over 3x to the fifth z to the eighth, right, would be an example of a rational expression where the numerator has just one term, so that's a monomial, and the denominator just has one term. It's a monomial. But it is a polynomial divided by a polynomial. X minus 6 over x plus 4 is an example of a rational expression, right? It's a binomial divided by a binomial in this case, but still a polynomial in the numerator and a polynomial in the denominator. X squared minus 3x minus 4 over x cubed minus 8, right, would be an example of a rational expression. A second degree polynomial, a trinomial in the numerator, and a third degree polynomial, a binomial in the denominator there. 2 over x minus 1 would be a rational expression, right? The 2 is a constant, so it's a constant term, but it still could be considered a 0 degree polynomial. And the denominator is certainly a binomial. So these are all rational expressions right here. These are all examples. So they can look really different. But as long as it's a fraction and as long as it's a polynomial in the numerator and a polynomial in the denominator, then it's a rational expression. Now these are things that are not rational expressions. So like if I have the square root of x minus 1 over x plus 2. When you have a radical like that, you do not have a rational expression, right? And so that this is not considered a rational expression when you have something like this. This is not a rational expression. And that's the only one I really kind of want to mention at this point. There are other kinds of rational things that are not rational expressions, even though they're fractions. They're not rational expressions. So right now, just know that if you have a radical like that, you don't have a rational expression. But there's, things like exponential expressions and logarithm expressions that you're going to encounter in college algebra that when those occur in fractions, you still don't have a rational expression. Trig expressions, trigonometry expressions, which for those of you who maybe are going to go on into a trigonometry class or the calculus sequence, you'd see that those are not rational expressions, right? It's got to be a polynomial and a polynomial. Polynomial on the top and a polynomial in the bottom. All right, now our first goal here is to talk about simplifying rational expressions. And when we talk about simplifying, we use something that you would have encountered back in probably 5th grade, somewhere back there with fractions. And it's called the equivalent fractions property. And the equivalent fractions property allows you to simplify a fraction, and it also allows you to simplify a rational expression as well. The equivalent fractions property says that if you have a times b over c times b like that, that's equal to a over c. Right? Now, probably the way most of you in your head or out loud actually say this is most of you say, well, I'm dividing out the b, right? That you're canceling a common factor, right? I bet a lot of you say that where you're saying, I'm canceling a common factor, right? I cancel the b's and I'm left with a over c, like that. When you cancel the b's, what you're really doing is you're really saying that it's b divided by b, right? You're really saying that a times b over c times b is really a over c times b over b, like that. And that those are the same thing. And then what's b over b equal to? Well, it's equal to 1. So the moral to the story here is, what can you do? You can divide out or cancel, right? I'll say or cancel. I actually try not to use that phrase because it's really not describing what you're doing, but I will say it too sometimes. But we're going to divide out common factors. Right? And if you go through and divide out common factors, then you're simplifying the rational expression or you're simplifying the fraction. So for example, if you just have 10 over 15, right? Well, that's a fraction that's not simplified. It's not reduced, right? That's probably what you might have said back in grade school or in high school. And the reason why it's not reduced is because there's a common factor between the numerator and the denominator, right? That 10 is 2 times 5, and 15 is 3 times 5. And then what can you do? You can use the equivalent fractions property to divide out the 5, and you're left with 2/3. And so 2/3 is considered, you might have said lowest terms. I definitely try not to use that phrase because the word term implies addition or subtraction in algebra, which we don't want. So I'm simply going to say that it's a simplified fraction, right? That 2/3 is the simplified version of 10/15, right? So that's what you try to do is you're trying to eliminate any common factors between the numerator and the denominator. So like 35 over 63, right? That fraction simplifies because the common factor there is 7, right? So you get the 35 is 5 times 7, and that 63 is 9 times 7. So you can divide out the 7s, and you're left with 5/9, right? And 5/9 is considered the simplified version of 35 over 63. Right, and so now as we start, making the jump into rational expressions where you've actually got polynomials in the numerator and the denominator, not just constants, you're not really doing anything different here. So if I have 21x over 28x squared, right, this is a rational expression. It's a polynomial in the numerator and a polynomial in the denominator. You can divide out a common factor here. And it's not a bad idea, especially as you're getting used to this, to actually write out the common factor here, that between 21 and 28, the common factor is 7. And between x and x squared, the common factor is x, right? So you have 3 times 7x in the top. And then the bottom, you've got 4x times 7x, right? And a 7x is something you can divide out. And so you divide that 7x out using the equivalent fractions property, and you simplified the fraction, and you've got 3 over 4x, right? This is the simplified version of the original fraction. So x's are factors just like the 5s were factors in the first problem, and the 7s were factors in the second problem. And so you can divide those out just like anything else. And if you want to formally write out the factor like I did there, it helps you keep things straight, so it's not a bad thing to do, but probably a lot of you don't do that, would be my guess, which is, not horrible, but it certainly starts getting a little bit messy when you start dividing out common factors. So if I have 40a cubed b over 45a squared b squared, you start getting all these little crossouts all the way through the fraction, and a lot of you kind of make a mess. This is not a hard problem, but you make it a mess because you've got all these crossouts in there, and you end up missing it because you've got a factor that you just kind of missed altogether. So you've got to kind of watch for that. So it's not a bad idea to actually formally write out the factor, or at the very least, just take this one factor at a time and make sure that you're dividing it out, correctly. So like at the very least, I'll actually kind of write it out both ways here. The 40 and the 45, the common factor there is 5, and so 5 divides into 40 8 times, and 5 divides into 45 9 times. And then with a cubed and a squared, you can divide out an a squared, right? And so you divide that out. And we've talked about just subtracting exponents also, but I'm going to look at this as simplifying. So that would leave you with an a to the first in the numerator and just a 1 in the denominator. And then finally the b's, divide those out. I can divide a b out right there, and it leaves me with a 1 in the numerator and a b in the denominator. And so the simplified fraction is 8a over 9b. Now the same problem, that's the simplified form right there. But the same problem if you identified the common factor, you could write it out this way. If you identify that 5 is a common factor, and 5 divides into 48 times, you have an 8 and a 5 here. And then and then in the denominator, 45 is 9 and 5, like that. And then the a cubed, the common factor is a squared. So I put an a here and an a squared over here. And the denominator, I just have an a squared, like that. And then with the b's, the b is the common factor, so I put a b over here, and no b's left in the numerator, and in the denominator I still have a b left, like that. And so what are you doing there? You are identifying that 5a squared b is the greatest common factor between the numerator and the denominator, sometimes called the GCF, greatest common factor there between the numerator and the denominator. Those divide out, and what are you left with? You're left with the 8a over 9b. So it's a different way of writing it, but it's the same thing, but it really kind of explains a little bit more about what's really happening there. So, Tricia, do you have a question?
Yes, Felicia. So good morning. So with the, I'm trying to catch up where you were. So it's actually you subtract the
You are subtracting the exponents. Yeah, so that's another way. You could look at that as a rule of exponents problem also, absolutely. And we did talk about that rule of exponents a week or two ago, and you could look at that as just subtracting exponents. But what are you doing there? You're subtracting exponents, but putting the variable where the bigger exponent was. So like with the a's, right, the bigger exponent was in the numerator, and with the b's, the bigger exponent's in the denominator, right? So the a ends up in the numerator, the b ends up in the denominator.
Okay. So that's what I need to figure out.
Is that what you were asking about?
Yes.
Okay, and Tricia, let me give you another example.
Okay.
Go ahead. I'm sorry. Did you still have a question?
No, you could go ahead.
Okay, so let's work another example that's kind of like that, and let's see how this works out. So let's say we have 18 a to the 5th b cubed c to the 7th over 12, let's say a squared b to the 8th c to the 9th, like that. So, you could go through here if you wanted to, certainly, and just divide out, common factors between each of the like factors there. So like with the 18 and the 12, the common factor there is a 6, right? So 6 divides into 18 3 times, and 6 divides into 12 twice. And then with the variables, what have you got? You've got really 3 separate problems there. You've got a to the 5th over a squared. You've got b to the 3rd over b to the 8th. And you've got c to the 7th over c to the 9th. And so in each case, you're subtracting the exponents, but you're putting the exponent at the end where the bigger exponent was in the problem. So a to the 5th over a squared, there's more a's in the top than in the bottom. So the a is going to end up in the numerator, and then you subtract. 5 minus 2 is 3. And then b to the 3rd over b to the 8th, there's more b's in the bottom than there are in the top, right? So you still subtract 8 minus 3 and get 5, but the b to the 5th is in the denominator. And exactly the same thing with the c's. There's more c's in the bottom than in the top. So when you subtract exponents, the c will end up in the bottom, right? C squared, like that. Right, so that's using rules of exponents, and there's absolutely nothing wrong with looking at it that way. That's absolutely fine. Another way you could have dealt with that is, for example, a to the 5th over a squared. Right, what are you doing? You're identifying that a squared is the common factor. And so you're dividing out an a squared, and that leaves you with an a cubed in the top. With b to the 3rd over b to the 8th, you're identifying that b to the 3rd is the common factor. So in the numerator, this is 1 times b to the 3rd. In the denominator, this is b to the 5th times b to the 3rd. And what happens? The b to the 3rds divide out, and you're left with 1 over b to the 5th. And then the c's, c to the 7th over c to the 9th. right? The common factor there is c to the 7th. So in the numerator, this is just 1 times c to the 7th. And the denominator, c squared times c to the 7th. C to the 7ths divide out, and you're left with 1 over c squared. So that's looking at it as far as looking at the problem as a fraction problem. And then you could, but like I said, rules of exponents are absolutely fine. There's absolutely nothing wrong with that. And looking at this as a rule of exponents problem also. So here I looked at it as a fraction, and I divided out a common factor. But a to the 5th over a squared, there's nothing wrong with just looking at that as a to the 5 minus 2 or a to the 3rd, right? They give you the same answer. It's an equivalent way of looking at it, and it doesn't matter which way you look at that kind of problem at all. Tricia, are you okay?
Yes, I'm getting it.
Okay. All right. Anybody else have a question before I go on?
I got confused when you started doing the a to the 5th over a to the 2nd. I just completely got lost.
Well, I'm just taking this a to the 5th over a to the 2nd, right? Kind of looking at that one little part of the problem. And I'm just looking at it two different ways, right? One way was just to subtract exponents and get a to the 3rd. The other way is you could cancel out an a squared, is all I'm saying. And those are equivalent ways of looking at the same problem. Either way, what happens? You end up with an a to the 3rd in the top.
Mm-hmm.
Right.
Okay, so that's the answer right there at the top. The 3a cubed over.
Right. That what I just put the box around is the simplified version, right? So 18 a to the 5th, b cubed c to the 7th over 12 a squared b to the 8th, c to the 9th simplifies as 3a cubed over 2 b to the 5th c squared, like that. This is the simplified form right here. And I was just pointing out above there the two different ways that you could think about it as far as how you get to that is all I'm really saying.
Okay.
So my guess is most of you are just fine with doing that, and you've got this little algorithm in your head, this little method in your head for how you do that kind of problem, which is just fine. And so don't let me mess you up in that respect at all. If you've already think you've got a problem like this, okay, then don't worry about that at all, okay? All right. Now what we want to do is we want to move on and start looking at maybe a little bit more complicated problems where there are addition and subtraction problems that are going on. So like, let's say we have 8x plus 16 over, let's say we have 10x minus 50, right? So now notice this rational expression has addition and subtraction in it. So one thing is make sure that you know you are absolutely not allowed to divide out those x's and those 8's. And so you cannot divide out factors in this form right here. And the reason why is you don't have factors. There is no factors of the numerator at this point, no factors in the denominator. You've just got a bunch of terms in here. You just have a bunch of addition and subtraction problems. And you do not have any fraction properties that would allow you to divide out terms like that. So you cannot, so let's go ahead and rephrase this. You cannot divide out terms or parts of terms. Only factors, right? And so remember, when we talk about factors, we're talking about multiplication. See, but the numerator is an addition problem and the denominator is a subtraction problem. And so there's nothing you could divide out like it is. Now, I'm not saying that this problem's simplified, though. And the reason why is because we can rewrite this so that we do have multiplication. In the numerator, there's a common factor of 8. And when you take out that common factor of 8, you're left with x plus 2. And in the denominator, you can take out a common factor of 10, and you're left with x minus 5. And see, now the 8 and the 10 are factors. It is a multiplication problem now. And so now I can go and divide out a common factor there. In this case, the common factor would be 2. And you can divide that out, and you're left with 4 times x plus 2 over 5 times x minus 5. And that's the simplified version of the original fraction. All right. Tricia, do you have a question?
Yes. Can you tell me what word is that you have in the parentheses after only factors?
That word is multiplication.
Oh, okay.
It's just my abbreviation for multiplication, and so let me write that actually all the way out like that. Right? So what I'm trying to get across here is that when you see the word term, right, in algebra, remember terms means adding or subtracting. And so when I say you cannot divide out when you cannot divide out terms or parts of terms, right? This is the operative phrase right here. You cannot divide out terms or parts of terms, only factors. What I'm saying there is if you have addition or subtraction, you cannot divide anything out. You can only divide out factors when you have a multiplication problem. Right, and so that's what we want to start talking about here, is when you can divide things out and when you can't divide things out. So let's when we're going to look at a ton of examples here, okay, to kind of discuss that. So let's say we have z squared plus 3z minus 10 over z squared minus 1. So the question is, can I divide out those z squares? Because they look common in the numerator and the denominator. And the answer is no. You cannot do that. And the reason why, right, this is not allowed. No. Why not? Z squared is a term, right? It's addition and subtraction. It's involved with addition and subtraction. And so you are not allowed to divide out those z squares like that. So what can you do in a problem like this to simplify it? Well, you can factor the numerator and the denominator. Right? You can rewrite them as multiplication. So in the numerator, excuse me, in the numerator, I can factor that as z plus 5 times z minus 2. Oops. Right? And in the denominator, that's the difference of squares. I can divide that or factor that as z plus 1 times z minus 1. And so notice in this case, no common factors between the numerator and the denominator. So there's no common factors. And so this is a simplified fraction already. Right? There's nothing I can do to simplify it. So it's simplified already. And so since it's simplified already, it wouldn't make any difference which form you wrote it in, right, as far as simplifying it, or as far as writing the simplified form. All right, let's look at next problem. Let's say we have v squared plus 8v plus 15 divided by v squared minus v minus 12. All right, so again, cannot divide out the v squares and the v's like that. So I'm gonna do that, but I'm gonna say off to the side no, because those are terms, right? These are all terms, are all addition and subtraction problems. So what can I do instead here? Is I can factor the numerator and the denominator. I can write those as multiplication problems. So in the numerator, this is v plus 3 times v plus 5. And in the denominator, I have v minus 4 times v plus 3. Right? Both were easier trinomials because the leading coefficient was a 1 there. And don't panic if if you can factor these, but maybe not quite as fast as I am. That would be understandable. I've been doing this for a long time. I'm several thousand problems ahead of you as far as practice on this. And so don't freak out. As long as you can get yourself through the factoring, don't worry about the fact that you may not be quite as fast at it as I am when I write it down. So do we have any common factors in this once we've written it as a multiplication problem? And yes, we do in this case. The v plus 3's are common. Right? Those are now multiplication problems, and so I would be allowed to divide those out. And so my simplified fraction is going to be v plus 5 over v minus 4. That's the simplified fraction right there. Right? I can't divide those v's out at the end because, again, those are terms, and so there's nothing I can do to divide those. Okay, so that's what we're talking about doing here. All right, next problem. And so please stop me if you have a question. Next problem, we have p cubed plus 3p squared plus 4p plus 12 divided by p squared plus p minus 6. All right, so I think now we've established the fact that I cannot do any dividing out in this form because it's all addition and subtraction. And so instead, what I have to do is try to write these as multiplication problems. Now be careful here in the numerator, there's 4 terms there. And so if you remember, a polynomial that has 4 terms factors, if it's going to factor by grouping. So that's what we're going to have to do in the numerator is use the grouping method. The denominator is just a trinomial that's relatively easy. Right? It factors as p plus 3 times p minus 2. But in the numerator, we have a little bit more work to do. Right? We're going to group this. Here's my first group. I'm going to go ahead and shade it. And then the second group, 4p plus 12. All right, so in the first group, the common factor there is p squared, and you're left with p plus 3. And in the second group, your common factor is 4, and you're left with p plus 3. All right, and now please do not. Still, can I do any canceling here at this point, or any dividing out of factors? No, because I still have addition in the numerator, right? So still cannot divide anything out here. There's addition in the numerator. Right, as long as I've got that addition in the numerator, I'm still not in a position where I can divide anything out. But I now know how to write the numerator as multiplication because I can divide, or I can take out the common factor of p plus 3, and you're left with p squared plus 4, like that. And in the denominator, this would be p plus 3 times p minus 2 still. And you see, now you're left with a common factor. Now it's all multiplication. And so now I can divide out these p plus 3's, and you're left with p squared plus 4 over p minus 2. P squared plus 4 is the sum of 2 squares, and so it does not factor. No way to write it as a multiplication problem. And so that would be my simplified answer right there. All right, wait until you've got everything written out as multiplication, and then see what you can divide out. All right, next example. So this is, let's see, 3x squared plus 30x plus 24 divided by 3x squared minus 48. Tricia, go for it.
Can
What?
you go back to that last problem, please? That's 2 squared plus 4.
So Tricia, do you have a question?
I was trying to finish getting that part, the last part down.
Okay.
Where
And let me, and the fact that it sounds like Trisha, you are taking notes, I think is absolutely awesome. That's great. And treating this like a regular, a face-to-face class where you're sitting there trying to take notes, that is awesome. And so that's a very good strategy to use. So it sounds like that's what you're doing, and I'm glad that that's what you're doing. And I strongly recommend that, whether you're watching live or whether you're watching the recorded version, sitting there and taking notes is a super thing to do. I would give you two pieces of advice through here.
I am.
Pardon me?
I said I am because this is not my strong suit, and being out of school for so long and then coming back trying to get this together.
Sure. No, I understand.
My son kind of helps me.
Two things I would tell you also. One thing you can do sometimes, students kind of forget this, but most of you have a phone in front of you that's got a camera, so that if you get behind, you can always take a quick photo of the screen, right, and go back and look at that page later. So that's one thing. I'm actually going to give you three little pieces of advice here. So that's one thing you can always do. So if you do miss something and the class kind of goes past it, take a quick picture of it so you can go back and look at it. Second thing, don't forget that I post these notes right after class. And so you have access to all of these notes at the bottom of my Google site. Remember, there's two places at the bottom of the Google site. One is links to the videos, the actual recorded lectures. So that's got video and sound and all that with it. But then there's also just the static copy of the notes down there in a different spot also. So you always have access to the notes. So that's another thing that I always want to make sure all of you guys think about, is that you can always go back and look at those notes. And I know some people who actually go and look at those static notes every time and actually print them off all the time after class and use those and kind of put together a little notebook for those. So that's another thing to do. Something else, this was a student from last semester, and this is something I never would have thought of, but he actually will go back and watch the video again. He actually attended live lecture and pretty consistently throughout the semester, not every day, but pretty close to every day. But he would, at work or sometimes at home, he would actually take the video and watch it again, but he'd watch it at twice the speed. And so he would double up the speed. That way he would take an hour and 15-minute lecture and watch it in 30 or 40 minutes. And he would actually go through all the material again, but in double time, and that allowed him to go back and reinforce a lot of the notes. So it's kind of an interesting perspective, and you have to try to discover what's going to work for you as you go through all this. And for different things are going to work for different people. So, but Trisha, the fact that you're taking notes is awesome, and that's a great thing to be doing. So I'm glad you're doing that.
Thank you.
And Trisha, also you have no problem stopping me, so that's good too. Now one thing you've been doing is hitting the raise your hand thing or something like that. I guess there's something that says raise your hand or something on there. And
yes.
And that's okay to do. I don't have a problem with you doing that at all. But I also don't have a problem with you just saying, hey, wait a minute, would you stop for a second, and shouting out. So that's okay also. So don't worry about stopping me either way. But you can do it whichever way you're comfortable is fine. All right, so here's another problem. We have 3x squared plus 30x plus 24 over 3x squared minus 48. Again, and the reason I'm going over this every problem is because this is such a common mistake. I cannot divide out those 3x squares because this is all addition and subtraction. So I'm not allowed to do that here. The only thing I can do is go through and write both the numerator and denominator as multiplication problems and see if there's any common factors in there. That's the only thing that I'm allowed to do. So in the numerator, don't forget you got GCFs. In the numerator, there's a GCF of 3. And when you take out the 3, you're left with x squared plus 10x plus 8. I think that's right. Yep. X squared plus 10x plus 8. And then in the denominator, there's a common factor of 3, and I'm left with x squared minus 16. All right, so those 3's definitely divide out. Right now it's multiplication, so I can divide those 3's out. Now you still have a little bit of factoring you can do here. The denominator is the difference of 2 squares. It factors x plus 4 times x minus 4. The numerator, on the other hand, x squared plus 10x plus 8, well, that's not factorable because there's no factors of 8 that would add to give 10. And so there's no way to write that as a multiplication. You're stuck with it like that. So you can either write your answer like that or like this one, x squared plus 10x plus 8 over x squared minus 16. Either one of those is acceptable as a simplified fraction. So if you write it in factored form, if you write it out not in factored form, it doesn't matter. To me, those are equivalent. All right, the next problem, this is to kind of go back and remind you about some factoring here. So you have x cubed plus 125 over x squared minus 25. So nothing I can do to divide anything out. But in the numerator, this is a cubed plus b cubed. And the denominator is a squared minus b squared. So remember those forms, and this is a good chance to review those for next week's test. But remember the sum of cubes factors a plus b times a squared minus ab plus b squared. And the denominator, a squared minus b squared, factors a plus b times a minus b. So don't forget those special forms for factoring binomials. So that means, you know, the numerator is x cubed plus 5 cubed, and the denominator is x squared minus 5 squared. So the denominator is the easier one. It factors x plus 5 times x minus 5. In the numerator, you get x plus 5 times x squared minus 5x plus 25. Right. And so you've got those factored, and so now the question is, do you have a common factor? And you do. The x plus 5's divide out. And then you're left with x squared minus 5x plus 25 over x minus 5. The x squared minus 5x plus 25 is not factorable. And so this would be my simplified fraction. There's not any dividing out I can do in a problem like that. So I do want to remind you of things like the difference of squares and the difference in sum of cubes, that you still have those things that may be usable to write out some of these polynomials as multiplication problems. All right.
I know you say that we're going to have to remember these. We can't take these into the...
No, sorry. Yeah, you got to. You definitely have to remember them. But you, Tricia, you are definitely capable of doing it. So don't sell yourself short at all. You can do it. What I've said before is what I recommend is that you write those forms down on your test as soon as you get the exam in your hands and start working on it. You know, at the top of the page, or there's going to be a cover page on it. You could use the back of the cover page. You know, however you want to do it, it's fine. But write them down immediately so you don't have to remember them, but just for a few minutes, and then you're done with it after that. Also, that means puts all the more emphasis on that exam review. That, you know, the more you write those forms down, the less you're going to have to worry about remembering those. So. But yeah, and it'll start coming to you more and more the more problems you do. All right, next thing I want to look at here, let's talk about a couple of things here. So first of all, x plus 5 over x plus 5. Well, if the factor is the same in the numerator and the denominator, right, you're dividing it out. And so what do you end up with there? You end up with 1. I mean, that's why you can divide out common factors, is because when you divide them, you get 1. So x plus 5 over x plus 5 is equal to 1. Now what about x plus 5 over 5 plus x? Well, because it's addition, it doesn't matter which order you write it in. That's still 1. Those are still the same factor. And so no big deal. That still divides out to give you 1. All right, now what about x plus 5 over x minus 5? Well, x plus 5 and x minus 5 are not the same factor, and so you cannot divide those out. That is already simplified. So this is already simplified right here. And then finally, what about x minus 5 and 5 minus x? Now this one is a little bit trickier to look at, and the way I would look at this, or one way you could look at this, there's multiple ways you could do this, but one way you could look at this is that if you just factor out a -1 out of the denominator, and you can always take a -1 out of an expression, but when you take out the -1, what you're doing is you're changing both signs. So, and think about that for a second. -1 times -5 is positive 5, and -1 times positive x is negative x. So those are really the same thing. And then notice that in the parentheses there where I have -5 plus x, if you just reverse the order of those two terms, just wrote them backwards, then you get x minus 5. And notice it's the same factors you had in the numerator. And so the x minus 5's divided out now, and you're left with 1 in the top and -1 in the bottom, and 1 divided by -1 is -1. So this is the moral to the story, is you don't really have to do this all the time in a situation like this one right here. These factors are what we call opposites of each other, and opposites are two fractions or two factors that look like this. One's a minus b and the other one's b minus a. Both subtractions, always got to be subtraction, but just subtraction in the reverse order. And so when you have a situation like that, you can divide those out, but what do? You replace them with a -1. Right? So compare that to this up here at the top. So when you divide a factor by itself, you get +1, and when you divide it by the opposite, its opposite, then you get -1. Right? And that, if you think about it, that makes sense in that what happens when you take 3 and divide it by itself? You get 1. But what happens when you take 3 and divide it by its opposite? 3 divided by -3 is -1.
So you just reverse the order.
Yeah, so the moral to the story is if you have two factors that are opposites of each other, you can divide those out. You just have to replace them not with a 1, but with a -1. So if you have, let's say you have this fraction right here, and you're trying to simplify it. Now, you do not have factors that are the same, but you do have two factors right here that are opposites of each other. 3 minus x and x minus 3 are opposites. And because they're opposites, then you are allowed to divide them out. But what do you have to do? You have to replace them with a -1. So what you do is you just put a -1 in their place. And what that ends up doing is that ends up changing the sign of the fraction that you end up with. And usually what happens is that -1 just gets put in front of the fraction like that as a negative sign. And you're just saying that it's the negative of x plus 2 over x minus 6. That negative shows up just as a negative in front of the fraction at the end. So the moral to the story, if you have two factors that are opposites of each other, you can divide them out. You just have to replace them with a -1, not a +1. So let's say I have 9 minus x squared over x squared minus 4x plus 3. So now in the denominator, I can't do any canceling because it's all addition and subtraction. So I go through and factor everything. And the denominator factors x minus 3 times x minus 1. And the numerator, now that's a difference of two squares, but notice the 9 is the first term. So that one factors 3 plus x times 3 minus x, like that. And what happens here, I've got two factors, 3 minus x and x minus 3, that are opposites of each other, right? They fit this form right here, a minus b over b minus a. And so what am I allowed to do there? I am allowed to divide those out. I can divide them. What do I have to do, though? I have to replace them with a -1. I just put the -1 in their place there. And then that -1 ends up just being a factor of -1 sitting out in front of the fraction. That's usually the way you write it, like that. So just something to be aware of, that you could get problems like that. All right. Okay, so now what we're going to do, and simplifying is still going to continue to come up, so we're going to encounter that a lot, but we're going to move on to operations on rational expressions. So operations on rational expressions means making sure we can add, subtract, multiply, and divide. When you see the word operations, you're talking about addition, subtraction, multiplication, division. Now, so let's look at, we're going to do multiplication and division now, and then addition and subtraction we'll do separately on Thursday of this week. Addition and subtraction are the harder of the operations. Now, with multiplication, I just want to remind you about rules for fractions. If you have a over b times c over d, if you're just multiplying two fractions together, all you do, remember, is multiply the numerators and multiply the denominators, right? Just multiply across. A times c and b times d. And division, if you recall on division, if you have a over b divided by c over d, then what you do here is you rewrite the problem as multiplication and you invert the second fraction. Now, I've had different students tell me different things that they use to remember that. I know that I have some students who like to say it this way, that they say leave, change, change. Leave means take the first fraction, just leave it alone. So it was a over b, you leave it as a over b. And then change, change means you change the operation from division to multiplication, and you change the second fraction by flipping it. Right, so I see some students just use those words a lot of times, and they'll say leave, change, change when they see a division problem. And, you know, if that helps you remember that, go for it. That would be fine. So just remember those three words. Now, the way I learned it is I just learned invert and multiply. Right, and that's the way I always said it to myself was I'm just going to invert and multiply. Invert means inverting the second fraction, change the operation of multiplication. Means the same thing, but... Okay, so if I have, let's just look at some very straightforward examples here. So if I have 2/3 times 5x over 7, right, then I'm multiplying those two fractions, those two rational expressions together. And so I can just multiply across and I get 10x, and multiply across and I get 21. And boom, I've got it done. And that's a simplified fraction and nothing left to do there. Super easy, just multiply across. Dividing is kind of the same, so you have, so it's pretty straightforward. 3x over 5y divided by, let's say we have 2z over 5, let's say 2z over 7. Then what's the first thing I do here is I rewrite the problem as multiplication. So you have 3x over 5y multiplied by 7 over 2z. And now just multiply across. And so you have 21x over 10yz. All right, all you're doing is multiplying across at that point. So you inverted multiply or leave change when you change the problem there. Right, so what did I do? I changed the division to a multiplication, and then I inverted the second fraction. Okay, let's say we have 6x over 7y multiplied by 14 x over 5y, like that. Now in this problem right here, you could certainly multiply across. And you do get 6 times 14 is 84. X times x is x squared. And in the denominator, 7y times 5y is 35y squared. Now, what might be hard to see here at this point, at the end, you might just leave that alone and say, okay, I'm done. But there's actually a common factor between the 84 and the 35 of 7. And that may not be easy to see with the 84 and the 35. But it was probably easier to see with in the original problem. And so usually what we do in a multiplication or division problem where you've got some simplifying you could do at the beginning, we usually try to simplify it first because it may be hard to see how it simplifies at the end. So like in this problem, what I might have done first is instead of multiplying across, first notice that there is a common factor of 7 that's sitting in there. And so I could divide out that 7. And that would leave me with the 2 right there. And a 1 right there with the 7. And now multiply across. Right? So you now have this problem, 6x over 1y. And you don't have to write the whole problem down again if you don't want to. I'm just going to. So now you have 6x over 1y times 2x over 5y. And now it's easier in that at the end you don't have to worry about simplifying it. You have 12x squared over 5y squared. And that's our simplified version. That might have been hard to see in this form right here, right? That there was a common factor of 7 in there. So that's why dividing it out at the beginning is not a bad thing to do at all. All right, so identifying common factors at the beginning is something that would probably make your life easier ultimately at the end of a problem. All right, so let's look at this example. Let's say we have x over x squared minus 9x plus 14 multiplied by x squared minus 49 over 7x squared, like that. See, this is what I was just talking about here. Multiplying across, you could certainly do in a problem like this, but it makes it harder to simplify it at the end. So instead, what I try to do is I factor every polynomial first, then divide out common factors, then multiply together. Right, and that makes your life a lot easier here, I think, when you do that. So in our problem, this would be x over, and then x squared minus 9x plus 14 factors x minus 2 times x minus 7. Right, and then multiplied by, and then x squared minus 49 factors x plus 7 times x minus 7 over 7x squared. Right, and so now it's probably easier, if you prefer, You could certainly write this all as one fraction. If this makes it easier to see how this is going to work out, then multiply across, but don't actually do the multiplication, right? Just leave the factors. This would definitely be okay to do, is just write it as a single fraction like that, and then divide out the common factors. The x minus 7's divide out, and then I do have an x that divides out also. It leaves me with an x in the denominator right there. And so then you end up with these factors left at the end. The x plus 7 in the numerator, and in the denominator you have a 7x times an x minus 2. And you can leave that one in that form, or you could write it as x plus 7 over 7x squared minus 14x. Either way, either one of those answers would be very acceptable. I would actually prefer the first one, but you could write it out either way. I would absolutely not have a problem with either one of those forms. So. All right, so I think we're doing okay here. The next problem I want to look at, if there's, and nobody is yelling at me so far, so I guess we're okay. Next problem I want to look at is 24z squared over 2z minus 8 divided by, so this is a division problem, so that's one thing to note in your head right away at the beginning, 4z minus 28 over z squared minus 11z plus 28, like that. So we see division, so we know invert and multiply. Invert and multiply. Or remember, you can say leave, change, change. Or if you have another way of remembering it. Either way you say it. So, and I'm also going to factor everything here at the beginning too. So I have 24z squared in the numerator, and then the denominator, 2z minus 8, there's a common factor of 2, and I'm left with z minus 4. I change the operation to multiplication, and then I invert the second fraction, flip it, and then I'm going to go ahead and factor everything at the same time. So in the numerator, z squared minus 11z plus 28 factors z minus 4 times z minus 7. And then in the new denominator, I have a common factor there of 4, and I'm left with z minus 7, like that. All right, so now you've got the problem changed to a multiplication problem correctly. Are we, John, is there a question?
No, sir.
Oh, okay. And so if you want to, you could certainly write this out as one fraction, just multiply everything together. This step is not necessarily required, but I think it's helpful. And then in the denominator, I have a 2 and a 4, which gives me an 8. And then z minus 4 times z minus 7. So it's, in this form, I think it's actually easier to see how things divide out. So what happens is z minus 4's divide out. The z minus 7's divide out. Now, frequently, I will get students tell me this is the final answer, 24z squared over 8. But this is still not simplified because there is a common factor there of 8. And so you can divide out the 8 there, and that leaves you with 3z squared over 1, or just 3z squared. That's the simplified fraction at the end, 3z squared. All right, and then let's see. I think what we're going to do is finish with this last problem right here. And so this was going to be, this be a relatively long problem. There's lots of factoring to do here. And so it's something you have to be prepared for, is that in multiplying and dividing problems, rational expressions, frequently lots of factoring going on in the problem. And so you've got to take your time. You mess one of the factors up and the whole problem's going to be wrong. So no pressure there, right? And so you've got to just be careful with each one of the problems, each one of the polynomials. All right, so this particular division problem ends up just being 4 factoring problems that you've got to deal with. You've also got to invert and multiply. So in the denominator, x squared minus 16 is x plus 4 times x minus 4, right? That's the difference of squares. In the numerator, it's not an easy trinomial, but you do know that the first terms are going to be 2x and x. Don't forget that you're trying to get a 1x here when you multiply these together. So if you put 2x plus 3 and x minus 1, notice that that works because that gives you a positive 3x and a negative 2x when you look at the inside 2 and the outside 2. So that works. And then we change the operation of multiplication. We invert the next fraction. So the x squared minus 8x plus 16 is in the numerator. That is actually a perfect square trinomial, and it factors x minus 4 squared. If you wrote x minus 4 times x minus 4, that would be wonderful. I wouldn't have a problem with that at all. And then 2x squared minus 9x minus 18, you do know that there's got to be a 2x and an x in the first terms. And you're looking for factors of 18 to fit in there. So you have 1 and 18 and 2 and 9 and 3 and 6 are all factors of 18, right? And you are looking for the outside 2 and the inside 2 to give you that negative 9x. Right, and so what ends up working here for that is if you put an x minus 6 like that, that gives you a negative 12x on the outside, and then a plus 3 on the inside, which gives you a 3x on the inside, and that does give you a negative 9x. So that's the factorization. All right, so if you want to, you could just now multiply this all out together and write it as one fraction. Like this, you get all these different factors in here, and there is quite a bit of dividing out you can do. And again, if you would prefer not to write this step out, you don't have to. I think it's a good idea to write it out. It helps you kind of keep things straight, but it's definitely not essential that you do this. The 2x plus 3's divide out. The x minus 4 is one of those divides out, so I'm left with an x minus 4 there, and that one divides out. And then that would be it. Those are all the factors that divide out there. And so you're left with x minus 1 times x minus 4 in the numerator, and in the denominator you're left with x plus 4 times x minus 6. Okay, so what you just need to be careful about is that there's lots of factoring. Take your time with the factoring, and it's going to take some practice here. What I'm going to do now is I'm going to give you textbook practice. These are good practice problems for the things that we looked at today. Remember, this textbook practice is not graded. The answers are in the back of the book so that you can always check your answers if you want. And I think the more of these kinds of problems you do, the better off you're going to be, certainly. The stronger you're going to be going into the first exam. So section 8.1, page 898, and it's problems 17 through 67, and I would say every other odd there would work just fine. Lots of practice problems there, certainly. And then on page 911, so this is, section 8.2, page 911. And then in this page, I would be looking at 73 through 107, probably, 73 through 107. And again, probably every other odd would be fine there as well. Remember, every other odd just means you start with an odd and then you skip odds throughout the list of problems. Those would be good practice problems here. So, All right, so as we finish up class today, we've done addition and subtraction. We've done multiplication and division and simplifying. Next time, just one thing that we're going to do, and that's addition and subtraction of rational expressions. Addition and subtraction is probably the hardest of the operations, so that's definitely something we want to spend a lot of time with. So that'll be our entire lecture on Thursday. That is where exam 1 will end, is with addition and subtraction. We will go on next Tuesday to new material. And then remember, next Thursday is when the testing window opens. And during testing windows, I do not lecture at all. So next Thursday, there won't be any lecture at all. Not this Thursday, there will be, but not next Thursday. So does anybody have any questions before we wrap up class today?
No questions. I'm pretty comfortable with this section.
Okay, good. All right, then if no questions, then you guys have a great, wonderful day. And I will talk to you again. Make sure you get in touch with me if you have any questions about something. Otherwise,